This is the CS159 Midterm 2 review. The goal of this video is to go through the practice exam and provide explanations for all the problems, along with clear up any confusion about any of the code or anything like that. A few notes about the exam. They have changed the format of it a little bit because of it being moving to online learning. The notes that Crum gave us said that there's going to be more questions about maybe like coding standards and coding ideas and theory rather than interpreting code, and this exam is a little more of interpreting code rather than theory or word problems, if you want to phrase it that way. Also, arrays are going to be on this exam, and they're not covered in this review or practice exam, so make sure you're okay with those. And then lastly, I'd like to just say thanks to Liam Robinson for inspiring me to do this video. His videos in 261 and 265 has been very helpful, so I thought I would give it a go and try to make my own video. Without further ado, let's get into the problems. So for the first problem, we're given this code segment, and just jumping straight to the question, it says, which of the following is the output generated by the first print statement in the code segment above? We're going to look, and it looks like we have some kind of short circuit logic statements here, and really once I see I have to interpret the code, I'm just going to go ahead and make a tracking table and go through it. So here I have that on the side of the screen. All right, so we're going to have X, Y, Z, and results, or result. And let's just set that to their initial values. So 7, 3, 11, and nothing. Then we go through the first line, and we see that X has a postfix operator, so we're going to have to increment that to 8. We're not going to evaluate that expression until, we're not going to evaluate it with the 8, we're going to evaluate it with 7 because it's a postfix. So we're going to use this, we're going to use the value of 7, and is 7 greater than 7? No, it's not, so this is going to evaluate to 0. That's really thick. Let's make that a little thinner. It's going to evaluate to 0. Then we have y++, so might as well take that and mark that down as 4. However, we're going to evaluate it, since it's a postfix, again, we're going to evaluate it with the initial value, which is 3. Is 3 greater than 3? No, it's not, so this is 0. Now 0 or 0 is going to result in 0, which means that the AND statement here, which has to have both be 1 or true, is going to be false, so we're never going to get to this plus operator. It's going to just stop here and move on to the next line. So that means that Z is going to stay as 11, and then result, this is false because 0 and some other is just going to short circuit to 0, so result will begin at 0. Now, moving on to the second line, we notice that we're going to have the plus equals operator for result, so we take the result and we add it. We don't assign it to result. We have x++ again, so let's go to the tracking table and just increment that again. And now, again, it's a postfix, so we're going to evaluate before we added that, which is, so we're going to use the value of 8 from the line above. 8 modulus 2 does equal 0, so this is going to be evaluated to 1, and then we move on to the next one to check that as well. We're going to use Z++, so we're going to increment Z to 12. But again, it's postfix, so we're going to use the value from the line before, which is 11. 11 modulus 2 is 1, which is not equal to 0, so this is going to be 0. So the result is going to be 0. We add that to 1, and we add that to 0, and we get 0. In this line, y did not change. Now, moving on to the last line, we have another plus equals. We're going to start off with y. We're going to increment it, which we didn't increment it in the line before it, but now it's going to be 5. Again, it's a postfix operator, so we use the previous value when we're evaluating the expression, which is 4. 4 modulus 2 is not 1. It is, in fact, 0. So this is going to evaluate to 0. And then we move on to, since this is an OR, we move on to the next expression, z++. Again, we're going to add that, and we're going to mark that down in our tracking table to 13. But we're going to evaluate it with the previous expression, which is 12. 12 modulus 2 is also 0. So we get 0 or 0. And that is going to be 0, so result is still going to be 0. Now we have tracked all of these values. We might as well just fill out this table as well, just to be sure. And now we can use this answer to answer the following questions. So, which of the following is the output generated by the first print statement in the code above? We are just printing results. We have 0. We look at the final line of our tracking table. We see it's 0. So the answer, therefore, has to be A. So moving on to the next question, it asks, what's the result? Which of the following is the output generated by the second print statement in the code segment? We look at the second print statement, and it's printing x plus y. Now we look at our tracking table, and we can see x is 9, and b is 5. So x plus y, 9 plus 5 is 14. The answer is C. Now the last question, what is the following output generated by the third print statement? That's simply printing z, which we had put in our tracking table as 13. Answer choice B. All right, moving on, we have a few logical expression questions. Question number 4, which of the following statements regarding logical expressions is false? When attempting to print the result of a logical expression that is true as an integer, the result will always be 1. Logical expressions are always evaluated and returned as integers, either a 1 or a 0, so that is true. So that is not our answer. Complementing a condition is one way to potentially remove negative logic from an expression. Complementing a condition is one way to potentially remove negative logic from an expression. That's true. Complements is equivalent to having an exclamation point, having negative logic, so you can use that to remove negative logic. Another C is a logical expression cannot be used as the control expression of the switch construct. Now, in the class, we don't use logical expressions, or they never showed us how to do this. But one thing that's really important to remember about C is that C pretty much lets you do basically anything. Almost anything you want to do in terms of logic, it will let you do. So this is actually false. You can use a logical expression as the control expression of a switch construct. So that's false. And so C is our answer. Moving on to 5, which of the following statements regarding the case label of the switch construct is false? First, A, the constant expression represented by a case label cannot contain any mathematical operators. That is actually false. Like I said in the previous question, C lets you do basically anything, and even though it may not be what you have learned or what you've used, you have to think about these edge cases, and C in this case does let you use mathematical operators in a case label. The next point, the case label represents an integral type to be compared with the result of the control expression. That's true. The case is compared with the control expression. If they're matching, then that case segment of the switch is executed. C, no two switch case labels can represent the same constant expression value. That is also true. They have to be, all the case labels have to be different. If two of them were the same, then the compiler would be confused essentially and wouldn't know which one to choose, so they have to all be different. So we're going to mark these as true. And the answer here is then A, because it's the only one that is false. All right, moving on to the next code segment for problems 6 and 7. This one, it looks to be kind of similar to the first code, some more postfixes and prefixes and adding to a result variable. First question is, which of the following is the output generated by the first print statement in the code segment above? So we're going to have to go through these first 3 lines of code, and I'm actually going to go back to a tracking table and just figure it out again. So what variables do we have? We have x, we have y, and we have z. And of course we have results. Now to start off with, we can see that 9, 8, and 4. And then I'm actually just going to go ahead and go through this first line here because it does not have any postfixes or prefixes on the variables, the x, y, or z, so I can just evaluate results of that first expression. This is asking, is x greater than y, is greater than z, and the key thing to remember for this problem is that it's equivalent to putting parentheses around here because the C compiler is not going to evaluate this as one whole expression, which is true because 9 is greater than 8, which is greater than 4, but rather it's going to evaluate this segment first, and then it's going to check if that's greater than z. Now, x is greater than y, that's true, 9 is greater than 8, so this is going to evaluate to 1. Is 1 greater than 4? No, so this is going to evaluate to 0. So result is going to initialize as 0. Now we can move on to the first line here of actual adjusting the variables, modifying the variables. And we're adding a result to result. We're not assigning it to result, so just keep that in mind. We have a prefix operator on x, so that's going to be 10, and it's a prefix operator, so we're going to use that new value when we evaluate the expression. 10 modulus z, which is 4, is going to be 2, so just write that down as 2. And then, is that greater than y minus y? That's a prefix for y, so let's just mark that down in our tracking table as 7. Modulus 4, which is 3. 7 modulus 4 is 3. Now, 2 is 2 greater than 3? No, it's not, so this is going to be 0. So, result 0. And z stays the same. Now we move on to the next line, and we get the same exact line, so we just repeat the same steps again. And we add 1 to x, so that's 11. We modulus that by 4, which is going to be 3. Z stays the same. And then we subtract 1 from y, so y is 6. Modulus 4 is going to be 2. And z stays the same. And then this expression, 3 greater than 2, that's going to be true, so that's 1. So result is going to have 1 added to it. All right, so that's the first 3 executing statements, and now it's going to output that result. Result 1, now it's 0 plus 1, so that's going to be 1. So the answer to 6, result 1 is 1. All right, now moving on, we have to continue with the code after to find the next question, which is, which of the following is the output generated by the second print statement in the code segment above? So starting off again, now they start to change it up a little bit on us. X++, that's a postfix, which is going to be set to 12, but we're going to use the value of 11 that was previously assigned to it. So, and then y is 6 plus z with a prefix, so that's going to be 6 plus 5 because we already added 1 to z, which is 9, so this is 11 does not equal 6 plus 5, which is 11, but 11 does equal 11, so that is going to be 0. Now, one thing that they do here is they change the plus equals that we were seeing before to an equals operator, so this is going to assign 0 to result, so result will now actually be 0. Moving on to the next line, we're now going to be adding the result of this expression to result, and we see that we have a prefix operator on x, so we're going to change that to 13, and then y stays the same, so just say 6, and then there's a postfix operator on 5. So that's going to be 6 plus 5, because we're using the previous value of z. 6 plus 5 is 11, so this is going to be 13 does not equal 11, which is true, so it's going to be 1. So we add that to result, and we get result is now 1. Moving on to the next line, we have x and y and z modulus 2 is equal to 0. Now using operator precedence, the first operator that is precedence is the modulus, so let's just put that in parentheses, and then the second operator that is precedence is the equals, so we can put this again in parentheses. So we're going to evaluate this first. Z is currently 6, modulus 2 is 0, so this is going to be 1, this whole parentheses section, and then we can just do these in order. So x is 13, and y is 6. Now remember that if the value is not 0, then it's true. So 13 and 6 and 1, all true, so this is going to be 1, which added to result will make result 2. And then x, y, and z stay the same for this problem. Now we have the printf, result 2. We calculated it to be 2, so the answer for 7 is C. Moving on to the logical statements. Question 8. Which of the following statements regarding selection constructs is false? The first says the conditional expression has 3 operands and a 2-token operator. The conditional expression, if you don't remember what that is the question mark with the colon, and then it has the conditional statement. The first statement is conditional, and then if that's true, it does the first executable statement, and then if it's false, it does the second executable statement. And it's asking, does it have 3 operands? Well, x, and then the true statement, and then the true execute, and then the false execute are the 3 operands, and then the 2 tokens is that if it's true, it will execute the true code, and if it's false, it will execute the false code. So this is true. The next B says the short circuit method of evaluating logical expressions is not applicable to the logical expressions of an if-else or an if-else construct. This is actually false. C is pretty consistent when it evaluates code, so it will apply those short circuit methods in the if-else and constructs. That is true. I mean, that is false. That it's not applicable. It is applicable. C maintains a fair amount of consistency, and you can probably assume that C will be consistent for the topics introduced in this class. And then C, the logical expression of an if-else construct requires enclosure in parentheses. That is true. This isn't MATLAB. You do need parentheses when you're writing an if-else. So the answer to B, the only one that's false. The answer to 8, the only one that's false, is in fact B. Moving on to 9, which of the following statements regarding repetitive processes is true? In an event-controlled process, we know the total number of times that the actions found inside the body of the loop will be executed. Event-controlled process means that it's not controlled by a counter, it's controlled by an event, usually an I/O event or an event by the user, an external event. So by definition, event-controlled means you don't have a number of the number of times that it's going to be executed. It's dependent on that event. So this is going to be actually false. Moving on to statement B. According to core standards, the use of the for loop must be limited to event-controlled processes. This is false. According to core standards, the use of the for loop must be limited to counter-controlled processes. So just swapped, because event-controlled processes are both hard to use with for loops and not allowed in the core standards. And then C, while the concept of recursion is not limited to pretest or post-test, it is a poor design to use it with event-controlled processes. That is true, because recursion, when used with event-controlled process, can continue going much greater than can continue executing much longer than intended if the event that is controlling it does not happen. And there is a limit on recursion called a stack overflow that could be triggered if the event never stops the recursion. So the answer to 9 is C. 10. Which of the following statements regarding looping constructs is false? Immediately following the update of a for loop will be the evaluation of the loop control expression. Now in a for loop, there are 3 parts separated by semicolons. The first one is the initialization of the variable to a certain value. The second one is the control expression, and the third one is the update action. And once the for loop is finished, it will do the update action, and then it will immediately check the evaluation of the loop control expression to determine, hey, do I run this loop again or do I stop? So this is true. B, the initialization of the loop control variable must take place outside the body of a do-while loop. So the good thing about a do-while loop is that it's always going to be executed once. And so if you wanted to initialize the loop control variable inside the do-while loop, you could do that because you know it's going to, at a minimum, be initialized once. So you can say this is actually going to be false because you can initialize the loop control variable inside the body of the do-while loop. C, in a while loop, the number of times the loop control expression is evaluated is 1 more than the number of times the loop will iterate. That is true. The final time that the while loop, or that the loop control expression is evaluated, is the time that that condition is false. So it will evaluate that control expression one last time, see that it's false, and then move on. So it will be n plus 1 number of times, where n is the number of times the loop will iterate. So this is true. And the answer is then B, because it's the only one that's false. All right, moving on. So again, we have a code segment for problems 11 and 12. The question is, which of the following is the output generated by the print statement in the code segment above? So we're going to have to evaluate this code. I'm going to go ahead and pull up my tracking table again, and we can start evaluating. We have 4 values this time: W, X, Y, and Z. And they start out as 0, 5, 10, and 0. Now for the first expression, and is evaluated before ors, so you have w and x, and you can just put that in parentheses, or y and z, and put this in parentheses, and then just, for the sake of it, put it in 2 more parentheses. And so y and x is 0 and 5, which is going to be 0 because w is 0, or y and z is 10 and 0, which is also going to be 0. And so 0 or 0, this entire expression is going to be 0, false. So we're going to move on to the first if-else. Moving on to the second expression, we have not w, which is 1. Again, we're going to have to evaluate the insides first, so just put in these parentheses again. Not w, so not 0 is going to be 1, and not 5 is going to be 0, so this is going to evaluate to 0. And then, or not y is going to be 0 because y is 10, and not z is going to be 1 because z is 0, but 0 and 1 is 0, so this is again going to be 0 or 0, which is going to be 0, so we're going to move on to the third else if, which is different this time because these are and statements and not, these are or statements and not and statements in the beginning, so we're going to have to change how we put our parentheses in and just say let's do these first because that's operator precedence. So not x is going to be 0 and not y is going to be 0, so this is going to evaluate to 0 inside this parentheses. So not y, w is going to be 1 or 0, which is going to evaluate to 1, and then 1 or not z, 1 is going to evaluate to 1. So this expression will evaluate to 1, and then y is equal to this will set y equal to 1. A lot of 1s. But we're just going to mark that in our tracking table now that we have a modification, so 1, 0. Then we have an else, but since this else if was ran, we're not going to go through the else, so we just go straight to the print statement, and it's just printing the 4 different variables, which we have as 0, 5, 1, 0, which is b. All right, now we're going to move on to question number 12, and I'm actually going to go ahead and erase these comments I made for the previous question so we can read the code a little bit better. And the question is, which of the following logical expressions from the code segment above are complements? And A, the logical expressions on line 10 and 14 are complements. Now complements means that the code will always be opposite, will result in the opposite result of each other. So if one segment of code is true, then the complement of that code has to always be false, and if the first set of code is false, then the complement of the code has to always be true. So we look at the logical expressions on line 10 and line 14, and to see if they're complements, we see that there are nots in front of the variables, but that does not make these expressions complements. You have to actually change the operators as well to get the reverse logic of the original expression. So we know that this are not complements, so this is going to not be true. Just cross it off. Now B, the logical expressions on 10 and 18 are complements. So now you can see that they changed the expression, but they've also changed the nots and put them in front of the variables. They've also not put in the necessary parentheses that would be needed to make the equation a complement given operator precedence of this and over these ors. So they are not complements. The logical expressions on line 14 and 18 are complements. So we compare them. We can see here, yes, the operators are switched like they would need to be for a complement. We can see that they are left as nots, which is correct. You don't need to you'd want to leave them as the same. You just want to switch the operators. But again, they have not put any parentheses in to these equations, so the logic will not be the same as the original. So line 14 and 18 are not complements. And none of them are complements, so the answer is going to be D, none of the above. All right, moving on, we have a few questions about for loops and constructs. 13. Which of the following statements regarding the for loop construct is true? The use of either postfix or prefix are interchangeable as the update expression of a for loop to increment the loop control variable by 1. So the update expression of the for loop, the last expression in a for loop, is never evaluated, it's just executed. So it doesn't matter whether it's a postfix or a prefix. It will always increment it by 1, and then moving on, it will be incremented, and that's the important part. And so since it's not evaluated, this is true. B, it is not possible to update the loop control variable of a for loop inside of its body. This is false. C, basically lets you do most things. If you're not sure about whether C would let you do something, it's probably a good bet to guess that it would let you do it. And in this case, yes, you can update loop control variables inside of the body of a loop. C, the compiler as used on the server this semester will permit a variable to be declared and initialized in the first expression of a for loop. The compiler on the server, GCC, does not allow you to declare and initialize a variable in the first expression of a for loop. This is false. And so the answer for 13, the only one that's true, is A. 14. Which of the following would not be a violation of course programming standards? Gotta love them. A, making use of a for loop but not using all three of its expressions. You have to use all three of the expressions as the course programming standards. So this is going to be a violation. The use of break to terminate a loop is also a violation. You're not allowed to use break in the course. C, allowing a single user-defined function to terminate in multiple places through the use of multiple return statements. That is also a violation. And so the answer to this question is D, none of the above, given they are all violations of course programming standards. If you have any questions about course programming standards, you can look in your note packet for the course programming standards section. They're kind of just pure memorization / practice through the labs and the homework. All right, moving on to this code for problems 15 and 17. I'm going to shrink this a little bit so that we can see it a bit better. There we are, and we get the first question, and which of the following is the output generated by the first print statement in the program above? And for this set of code, I'm not going to set up a tracking table because we're not actually modifying any variables. We're just checking those variables against these expressions. And we can see that the first print statement is printed only after the first line is executed, which is essentially plugging three numbers into leap1 function and then outputting the results. So looking at the leap1 function, first thing it's going to do is it's going to do year modulus 4, and then if that is greater than 0, if that's 1 or greater, it's going to return 0. Now, we know that in this case, all of these three numbers, 1900, 2000, and 2020, are divisible by 4. So we can just remove this chunk of code. We can ignore it for now. We can ignore this code, just credit it and move on. So then we have this next expression, which is if the year is divisible by 100, and in this case, it's checking if the year divisible by 100 is 0, and then if it is 0, it will return a 1, and then it checks if the year is divisible by 400, and if so, it returns a 1, and then if it's both divisible by 100 and 400, it will return 1, and otherwise it will return 0. So in essence, what this is asking is which of these numbers is divisible by both 100 and 400. Now, the only one that's divisible by 100 and 400 is 2000, and then these two are both not going to be divisible by 100 and not going to be divisible by 400. So the answer to this first statement is going to be 1. That's going to be assigned to leap. It's going to be printed out. The answer to 15 will be B. All right, moving on down the page a little bit here, we get to question number 16, which is dealing with the second output statement printed in the program. And so we're going to go through the same logic. The logic is a little different this time. We're going to run through the leap2 function. First thing it's going to ask, this not year modulus 100 is going to do the same thing as it did in the previous function. It's going to say, is this number divisible by 100, and then return 1, and is it also divisible by 400, and then if so, return 1. So we know, hey, one of these years, 200, is actually going to be divisible by 100 and 400, so it's going to return 1. So I'm just going to write that down now. Leap2 2000 is going to return 1. Now, 1900 and 2020 are not going to return 1. They're going to have to go through this other expression, which is going to ask, oh, hey, it's not year modulus 4, so if this is divisible by 4, this is going to return 1, and so it's going to select 1 and return 1 in the function. So we know, hey, these are also, these two 1900 and 2020, they're both going to be divisible by 4, so these are both going to evaluate to 1, and the end result is going to be 3, so the answer to 16 will be C. All right, moving on to the third function, we can see that the actual operation of it is a bit closer to maybe the first function than the second function, where the first thing it does is it checks is if year is divisible by 400 if it has a remainder, and if it does, then it will go into this internal code. However, we know that there's already 1 year here that is not going to have a remainder, 2000, so that will just evaluate to 1 and ignore what's inside the parentheses. So we're just going to go and write that as 1 right away. Now for these other two numbers, we're going to see the second expression is very similar. It just checks, is there a remainder when year is divided by 100? And in this case, 1900 will not have a remainder, which means that we can skip what's inside this parentheses, the internal parentheses, and just go to 0. So we know that leap3 1900 will be 0. And then the last number, 2020, will have a remainder when it's divided by 100, yes. Will it have a remainder when it's divided by 4? No. So the result will be 1. So the answer of this expression is 2, leap is assigned to 2, and it's printed as 2, so 17 is C. Now, one thing that's important to see here is that looking at these equations, they don't really, these are all leap years, 1900, 200, 2020, 1900, 2000, 2020. They're all leap years, but these functions don't necessarily return whether or not it's correct or not. So oftentimes, even though the function is named leap, it's not, or maybe it's renamed factorial, as we'll see later, it's not going to actually return the factorial, or the behavior is not going to be as expected. All right, now we are going to move on to the next page. And we have code for problems 18 to 20. we have a main statement and then a subfunction called days of the month. And question 18. Which of the following is the output generated by the first print statement in the program above? Here I'm looking for any variables if I should make a tracking table. I don't actually see any. I see days, but it doesn't look like that's going to be changing multiple times. It looks like it's just going to be changed in the case statement. So the first statement is going to take days a month. It's going to input 10, and then it's going to print that. So we can go through with a value of 10 as month. Days is set initially to 0, and then it switches based on that input of 10. So we go down to case 10. Now we see there's nothing there. However, the coder of this code forgot to put break statements after every case, which is what you need in order for it to not continue executing. So it's actually just going to continue executing all of these cases until this first break here. So that means that days is going to get added 1 to it, and it's also going to get added 30 to it. So the end result will be 31 days. 1 plus 30. Now, the result is going to be 31, so the answer for 18 will be C. Moving on to question 19, which of the following is the output generated by the second print statement in the program above? So now we're going to be inputting 11 instead of 10. So it's going to set days back to 0, and it's going to put in 11 into the switch instead of 10. We go down to case 11. We see there's no breaks underneath that, so it's just going to go through all of these cases. And case 11 is going to subtract 1 from days, so it'll be -1, and then nothing's going to happen until case 7, which it also executes, which adds 31, so the end result will be -1 plus 31 is 30. So the answer of 19 is 30. Now 20, do the same thing except with the third statement, which is 2. So we're going to be putting in 2. We're going to be starting at the very first case statement that they have here, which will be subtracting 3 from days, which is -3. Then just continue executing until you hit that break. Add 1, -2. Add 30, you get 28. Instead of 31, which we had the first time when we put in 10. So the result of 20 is 28, which is not a result listed on the results, which will mean that the answer choice is actually D. All right, and then let's move on to the next page. And we can fit this again. Now we have a much shorter section of code for problems 21 and 22. However, it is repetition, so we'll have to probably want to make a tracking table for this code. So let me just get that pulled up real quick. There we go. And we only have one variable, so that does make it pretty easy in terms of keeping track of different variables. Now we have to actually interpret what the code does. Let's just read the first question so we know what we're doing. Which of the following is the output generated by the print statement in the code segment above? So we've got to find that final print statement, which is going to print x modulus 10. Now let's interpret what the actual while statement is doing. It's while x is not divisible by 2, when it has a remainder when it's divided by 2, it's going to subtract, it's going to divide, do integer division, divide x by 10, and then it's going to add 1 to x. So, and x is going to be initialized as 520463. So let's see how this turns out when we actually go through the code. So the first time, is x divisible by 2? No, it's not. So let's go through the while loop. It's going to divide x by 10, which is 520464646. But then it's going to add 1. So it's going to be 47. And we go through the same process. I made a mistake there. 52047. And then we're going to go through the same process again because it's not divisible by 6. So 5204, add 1, 5, not divisible by 2. So 520, add 1, 521, then 5252, add 1, it's going to be 53. And then still not divisible by 2, so you're just going to have 5, add 1 is 6, that's divisible by 2, and that will stop the actual execution of the code. So the final value of x, when it's printed, is going to be 6. Now, it's actually printing 6 modulus 10, but 6 is smaller than 10, so if the smaller number modulus a bigger number, it's always going to be the smaller number, the first number. So 6 modulus 10 is still 6. So the answer to 21 is B. Now, moving on. I have covered up one of the answer choices here, but C is 4. Moving on to 22, which has the same exact answer choices as answer 21. So let's just say final x is 4 here, just to remind you. And then D is none of the above. We have, which of the following would be the output generated by the print statement in the code segment above if the variable x were initialized to 826049? So now we're going to have to do this again, and I'll just put this in the second column here just to compare the two. To compare the two. All right, so starting out, we have 826049, and then is that divisible by 2? No, so 82604, add 1, 5, then 8260, add 1, 1, and then 826, add 1, 7, and then 82, add 1, 3, and then 8, add 1, 9, and then that's still not divisible by 2. All right, so x divided by 10 is 0, so it'll be 1. And then we have an infinite loop, actually, because the code never finishes this, because it's going to divide it by 10 and 0, and then it's going to add 1. So it's going to keep going as 1 forever. Therefore, the output is not going to be generated, so the answer will be D, none of the above. Moving on, this is for problems 23 and 24. And there's a if statement inside of a do-while loop with three variables, x, y, and target, and we're just going to go ahead and put those into our tracking table here and initialize them 19, 22, and 1. We go through the loop, we go through it at least once because it's a do-while. So starting off, it asks, is x plus y divisible by 2? It is not. 121 is not divisible by 2. So it's going to be going through the else statement. So it's going to be adding 1 to y. So 99, 23. And then it's checking, hey, is x modulus y greater than the target? the target is still 1, and 99 modulus 23 is greater than 1. So we are going to continue with the loop. And we're going to ask, hey, is x plus y modulus 2, is that equal to 0? Is it divisible by 2? And in this case, it is going to be divisible by 2. So we're going to subtract 1 from x. So x becomes 98. Y stays at, say, 23. Now, 28 and modulus 23 is still greater than 1. So we go through the loop again. And 98 plus 23, hey, that's not going to be divisible by 2, so we're going to keep x the same and subtract 1 from y. And essentially this pattern is going to keep repeating until you get to the point where x modulus y is not greater than, the target is not greater than 1. So I think I made a mistake in my tracking table there. You're incrementing y, not decreasing it. But eventually you get to 97, 24. 97 modulus 24 is going to be 1. 1 is not greater than 1, so the while loop at that point ends. Your last values of x are 97 and 24. So the answer will be B. Now moving on to question 24. Which of the following would be the output generated by the print statement in the code segment above if the variables x and y were both initialized to 10? So you could fill out this tracking table. However, that would be a bit of tracking and it'd be a pain. I'm just going to look at these results and see, hey, maybe there's a shortcut, maybe some of these are going to be invalid results. And we know that the condition that these last have to be true is that x modulus y has to be greater than target. The target is going to stay the same. It's going to be 1. So we check, hey, is x modulus 19, would that work? Yes, 1. Modulus 19 would work. Yes, so 1. 1. 1. All right, so these are all going to return 1, and they're all valid expressions. But which one would be triggered first? Which one would you get to first in the code? And the answer to that is, well, it's incrementing y, and then it's decrementing x. So the one that's the least progressed is going to be B, because it's going to go 1, 18. Oh, and let me just put this in my tracking table. So it would be 1, 18, then 1, 19, then 0, 19. The first one that's going to trigger this expression is 1 and 19. Well, sorry, 1 and 18. So that must be the answer. It must be B. Moving on to the program for problems 25 and 27, we have a whole bunch of code that looks to be calculating something. I'm just going to read what is the first question. It says, which of the following is the output generated by the first print statement in the program above? So looking back up here, we can see that the first print statement is just going to return what happens when you input 50 and 1 into the first function, into the function. So scrolling down here, we're inputting 50 and we're inputting 1 into the function. So let's look at what this function is doing. It's dividing x by 2 and it's looping that many times, starting from x divided by 2 and going down to 1. So in this case, it would start at 25, go to 24, 23, 22, all the way to 1. And then it's checking if the number is divisible, if the number is divisible by that number, if 50 is divisible by I, if 50 is divisible by 25, if 50 is divisible by 24, if 50 is divisible by 23, all the way to 1. Then there's a switch statement. If option is 1, it's going to increment the total by I which in this case would be the factor. So what this for statement does is that and this for and if statement do is they find all the factors of x, including 1, because it starts at 1. And so, and then depending on the switch, in the first case it adds it to a total, and then in the second case it just increments, it counts how many factors are there. So instead of actually running through this code, I'm just going to use this knowledge, oh, I know what it does, and I'm going to say 50, how many factors of 50 are? Well, there's 1, 2, 5, 10, and 25. So 35 plus 5 is 40, plus 2 plus 1 is 43, so the answer to 25 has to be C. Now, 26, which of the following is the output generated by the second print statement in the program above? And so now the second print statement, if we scroll up here, we can see that it's inputting 2 instead of 1. So instead of going through this first statement where it sums all of the total, it's going to count all of the factors instead of summing them. How many factors are there? There's 5 factors. The answer to 26 is B. Now we have a bit of logic about the function. Again, we see here that it's asking us, like, what are the number of factors? Is it a prime? You know, it's asking, hey, do you know what this function is doing, not just can you plug it into a tracking table? So it's important to distinguish in this problem. It's not actually wanting you to make a tracking table, it's wanting you to understand, hey, what is this function doing? And so if you see, oh, there's a big loop, you know, this is going to take me 5 minutes to go through with the tracking table, it's probably going to be, hey, let me think about this program, let me see what it's actually doing. So question 27, which of the following statements regarding the make total function in the program above is false? It says when the option is 2, when you're switching to the second case statement, the value returned is the number of factors of the integer x. So that is what we determined. Yes, since this activates, the switch statement activates for every factor, it is going to be the total number of factors. When option is 2 and the value returned is 0, then the integer x must be prime. Now, there's a factor of all numbers is 1, and this goes to 1. It is I is less than or equal to 1. So it will run through 1, and it will always find that factor, and it will add that to the total. So the total is always going to be at a minimum 1, so the value returned will never be 0. So this is actually false. And then when option is 1, the value returned is the sum of the factors of the integer x. That is true. That is what we determined in the previous, when we looked at the function of the code. So the answer of 27 is B. Another thing is they give you this. We didn't look at this question until we were done interpreting 25 and 26. But if you were confused about, hey, I don't really understand what this is doing, and you just read ahead, oh, 27, and it said the value returned is the number of factors, is that how this works? Maybe let me double check. Let me see if this will help me understand the code. Just a little test taking tip there. All right, so answer of 27 is B, and let's move on to the next page. There's another set of code here, and it's asking, hey, what's the following is the output generated by the first print statement in the program above? Here, looks like, again, now there is a bit of code. We're probably going to want to have some tracking tables in this problem. We can see that we have a do while in the main function and then a while loop in the actual make total function. So we're going to have to plow through this. I'm going to shrink this up a little bit, and so we can see a bit more of the code. There we go. The problem, and then I will open up my tracking table again so we can review the problem. There we go. All right, so we have 3 variables. We have x, we have iterations, and we have total. So let's just put that in there. And we initialize this as 4658172, which is 0, and total 0. Cool. So do while, we execute it at least once, so we can start off. We're going to put make total, and we're going to put in x, which is 4658172, and then we're passing iterations by address, which is correct. You're referencing it here, and then when you reference this count, you're referencing it with the asterisk. So you're going to change that value both in the function and the main function there. So looking at that, I'm just going to keep track of the function I'm calling here. Make total, and then the number 4658172, and iteration starts as 0, right? So we're going to go and we're going to figure out what this make total is actually doing. We see there's 3 variables in make total. There's x, there's total, and there's count, or CT. X we know is going to start out at 46558.58172. Total is starts at 0. Count starts at 0. Now, what this function actually does is, well, it's going to check if it's greater than 0. It's going to add 1 to count. It's going to add the last digit to total, which is 2. And then it's going to check, hey, is the number divisible by 2, then divided by 10, and then divided by 10 again, regardless of whether it's divisible by 2. So in this case, it is divisible by 2, so x is going to change to 46581, and then we're going to go through the while loop again until x is not greater than 0. So 4658. Add 1 to total, which will make it 3. Add 1 to count, which will make it 2. Go through it again. 46, because x is divisible by 2. Add 8 to total, but not 5, which will make it 11. And then add 1 to count, make it 3. And then it's again divisible by 2, so make the x 0. Make total, add 6 to that, so make it 17, and then add 1 to count. And then we return that total, so we're going to return 17. So total in the main function is going to be changed to 17. So we might as well change that to 17 for now. And then iterations is going to be 4. And then it's going to check, hey, is x, and then it's going to divide x by the 10 to the power of iterations modulus 4, which would be 0 plus 1, so it's going to divide x by 10, so x would then be 4655817, and iterations would stay the same, and total would stay the same. And then we're going to have to go through make total again with these new variables. So let me just write it in as make total 4655817. 4655817, comma 4 is our iterations for that second variable. That is going to result, and I've already calculated it out here, as a result of 22, and iterations is going to be 8. Result will be 22, so 22 plus 17 is 39, and then the x, so we take that, we say iterations divided by 4 is also 0, so we divide it by 10 one more time, and x is going to be 46581. So then we run make total again with the 8 being 4681 and iterations being 8. Now the result of that, I've also calculated it, and the result is 15. So 39 plus 15 is 54. Iterations is now 11, and so 11 modulus 4 is 3. 10 plus 1 is going to be 4, so 10 to the fourth is 10,000. So when you divide that x by 10,000, you get 4. So then we run make total again, and we just have 4 and 11. And the result of that is going to be 0 as the final value for x, and then 12 iterations, and then 4 as a result. And then you add that to 4, you get to 54, you get 58. So 58 will be our final result. Now that's a bit of work to go through. You just have to chug through it. I don't think there's any way to go through it faster or easier. You just gotta make up a tracking table and figure it out, plot through the numbers. Maybe this would be a good problem to do at the end of the exam when you have more time, when you've answered all the other questions. So end result for total, which is the question for 28, that's going to be C. And then 29 asks what the output generated by the second print statement in the program above. We figured out that the iterations is going to be 12. And actually you can't see that because it's not in the thing. So let me just copy that and paste that up here. There you go. This is the final run of make total. You put 4 and 11 in, and you get 0, 12, and 58. So the last value of iterations will be 12, so the answer of 29 is B. I do recommend that you go through this by hand and calculate it. It's just good practice. It's the most difficult question on the entire exam, so you'll learn how to go through the whole process of doing a tracking table. All right, moving on to our last code segment, which is problems 31 and 39. I'm just going to remove my tracking table here so we can read the code a little bit better. And it says use calc factorial is the function, main is the main function, and it says which of the following is the output generated by the print statement in the program above. Again, now we can see, we look at calc factorial, we see it's actually a recursive function. It's calling itself. So we're going to have to trace this function down. We're going to have to see what its value is. We're inputting these 3 numbers. And so I'm going to pull my tracking table right back up, and we can track this trace of this function as it calculates, I guess, the factorial of one of these numbers. All right, so when doing these, I think it's useful to write down these different functions and the function calls that you're going to be using. So the first function call will be calc factorial 7 to 5. And then we can actually figure out, hey, what is the next call of calc factorial going to be? And we can see that it's going to result in, we plug in those numbers, we're going to see, so these will be 7, 2, and 5. In factorial is 1, n is greater than 1, is n greater than a? Yes. 7 is greater than 2, and is n less than b. Is it less than b? It's not less than b, so we're going to skip this first if and go straight to the else. And so then it's going to set fact equal to, it's going to set fact equal to factorial n minus 1 a b, and then it's going to return that factorial. So we're going to make this, and we're going to use the equal sign in this. Hopefully that lets me. So essentially the first one is going to be equal to calc factorial times, what's n minus 1? Well, that's 6. A is still going to be 2, and b is still going to be 5. Let's see if it lets me display that. It does not let me display that. That is annoying. We'll just use the word equals. That's going to returns. Actually, we're going to use returns instead, because that's more accurate. So that's what that first function is. Now we have to see what is it going to be when it's 6, 2, and 5, and hopefully we'll be able to see a pattern and just be able to quickly figure out what the actual result is. So 6 is going to be greater than 1. It's not going to be great. It's going to be greater than a, but it's not going to be less than b. So we go again to this function, and we're just going to write that back in a tracking table. Returns calc factorial, but this time it's going to be 5 instead of it's going to be 5 instead of 6, and then we change that 6 to a 5, and we see, hey, in fact, it's greater than 1. Is it greater than a? Yes. Is it less than or equal to b? Yes, it is less than or equal to b. 5 is equal to b. 5 is equal to 5, n is equal to b. So we go through the first one, and this is going to return n. It's going to return 5 times calc factorial n minus 1 a b. So that's going to be returns 5 times calc factorial 4 to 5. Cotrial factorial. So now we change it to 4. And we do it again. Well, it's going to be 4 times, 4 is greater than 2, and 4 is less than 5, so it's going to go 4 times the calc factorial 1 minus 2. Well, when is this going to stop? It's going to stop doing this when n is 1, and actually when n is 1, it's not even going to run this if statement at all, because it's going to just return factorial, which will be 1. So basically what I'm saying here is that we can continue this pattern until n is 1, and when n is 1, then calc factorial will equal 1. So I'm just going to fill that out here. Alright, so I have it all filled out here, and just to remind you what this actually means is what each line is what the previous function call is doing. So starting at the bottom here, we have returns 1. Well, that's what calc factorial 125 returns. And then returns 2 times calc factorial 125 is what calc factorial 225 runs. And so we can see that it's going to be 1 times 2 times 3 times 4 times 5. And then return, return, return. It's going to return this 4 times 5 times 4 times 3 times 2 times 1. So the end result of the entire trace is going to be 5 times 4 times 3 times 2 times 1, which is 120. So the answer will, in fact, be C. All right, moving on to the next question. It says, how many total times is the calc factorial function called in the program above? Well, we can count how many times did we call it. We called it 1, 2, 3, 7 times. So the answer to 31 is 7. A. And now we are done with code. So let's go through a few of these selection and repetition constructs in the next function. Let me remove my tracking table. All right, 32. Which of the following describes a use of selection or repetition constructs within the main function according to course standards? A. The use of a do-while loop for the validation of input given by the user. That is actually not allowed in the main function because I/O must be in its own function according to course standards, so this is not the right answer. The use of a switch statement to select the correct printf statement to execute. Again, I/O is not allowed in the main function, so this is not true. And then C, the use of an if-else construct to select the correct user-defined function to call. And selection is allowed in the main function. Limited selection is, I think, the phrasing they use. So this is true. This is the answer. 32 is C. Now moving on to 33. Which of the following would be considered a good design with respect to the efficiency of instruction execution? So the first one is coding the most frequently true logical expression first in an if-else construct. And that is true because if you have the most frequently true expression first, then the amount of times that you're evaluating false expressions or evaluating expressions that you don't need to evaluate is going to decrease and it will be more efficient. So that's true. For 33b, using a for loop rather than a while loop when a pretest construct is necessary is not going to be efficient because the while loop is the way you test for a pretest construct, and so you'd have to put in like another if statement or something like that. So this is going to be false. C, implementing consecutive if constructs rather than making use of an if-else construct. So if-elses are useful because you know the second amount of code is not going to be evaluated, it's not going to be executed, because of if-else only goes to else if is false. So just implementing consecutive ifs is going to be less efficient than using if-else. So this is also false. And so the correct answer for 33 is A. 34. Which of the following would not be considered a counter-controlled process? A, the repetition used in the code for problems 21 to 22. B, the repetition used in the code for problems 23 to 24. C, the repetition used in the code for problems 30 to 31. So at this point in the test, you're freaking out. You're going, oh, I need to go back and look at all these different problems of code. There's probably like 2 minutes left. You know, you got to submit it. And, you know, why did they throw in this question that makes you review all the previous code? Well, the question is asking, which of the following would not be considered a counter-controlled process? Well, what's not a counter-controlled process would be an event-controlled process, which would be an event such as the user inputting the incorrect value. And all of these functions, all of these programs and code that we looked at did not have any user input. They did not have any events in them. They were all controlled by counters. They were all controlled by numbers that were defined in the function. And that's why we were able to evaluate them like the compiler is, because they did not have any external events occurring. So the answer for 34 is D. And I just saved you from having to go look at all of the different code in the test and waste a bunch of time. 35, which of the following is a requirement to receive any credit for the exam? Your name and student identification number, yada, yada, yada. You are seated in your assigned seat. The cover of this exam lists your CS159 instructor. I'm guessing none of those things are going to be true because we're all going to be taking the test on Blackboard. So I don't know. This entire question, invalid, incorrect. Anyway, I hope you enjoyed this review. It was an interesting experience making it. Hopefully it was helpful for you in your understanding of the program and your review for the test. Good luck, and goodbye.